This video is just for fun. I love the Jurassic Park franchise, and invasive ecology is one of the things that I am passionate about. I am basing this video off of the opinions of a few experts and myself. That's just it. Opinions. Based on a fictional franchise with genetically altered animals with modern day science and examples. Enjoy. Just like most kids, I was obsessed with dinosaurs. I had the books, I had the toys, I had the magazines, I watched the TV shows, I watched the movies. Then, when I was 5 years old, Jurassic Park came out, and it changed my life. I was both terrified and fascinated by this movie. Then, last year, the last installment of this franchise came out, Jurassic World Dominion. Now, if you don't want spoilers for the movie, then I suggest you go watch it, and then you come back to watch this video. Still here? Great. This movie portrays the scenario that a whole bunch of extinct animals, 30 species to be exact, just get dumped into our modern world. Now, I know how I would react, personally. But it does kind of throw out a couple questions that we should really ask ourselves if this were to actually happen. One, would dinosaurs be able to survive?
Well, the question is, how can you know anything about an extinct ecosystem?
And two, how my mind works, would they become invasive species? If you are new to the channel or the term invasive species, be sure to subscribe to learn more about them. An invasive species is any species that gets introduced into a new area and causes harm to the economy, the ecosystem, or human health. Now, I'm sure some of those dinosaurs would be pretty detrimental to human health. Before we can answer, would they become invasive, there are some other questions to ask. Like, would today's climate be able to sustain them? I mean, in the Mesozoic era, the temperatures were a lot warmer than the present. Like in the Cretaceous period from 145 million years ago to 66 million years ago, the global average temperature was around 4 degrees Celsius higher than that of today. Plus, oxygen and carbon dioxide levels were pretty different in those periods as well. Today, our atmospheric oxygen is around 20.95%. In the late Cretaceous, it's thought to be an average of 30%, which higher oxygen levels are linked to larger animals. Like 300 million years ago in the Carboniferous period, it was thought to be over 30% atmospheric oxygen and led to some of the largest arthropods the world has ever seen, like the Pulmonoscorpius or the Meganeura. Terrifying to think a scorpion or a dragonfly this large flying around right now, huh? Another important question is, would today's plant life be consumable for the herbivores featured in the film? Most large herbivores of today, especially domesticated animals, are fed hay. Mine included. Alfalfa, which is a legume, is a major one. But legumes evolved around 60 million years ago, after the time of the dinosaurs. Grasses are the same, evolving 55 million years ago, although there are grass-like plant fossils in dinosaur feces, but it doesn't resemble that of today's grasses. And modern-day herbivores that feed on grasses have specialized stomachs that let the grasses ferment. Okay, I know that they're genetically modified species and they use modern-day animals' DNA to fill in the gaps. So, for our sake today, let's just say that they are able to survive in our modern-day climate and atmosphere, and they are able to digest most of our modern-day vegetation. Now, how much of this modern-day plant life is needed? I mean, there are some very large dinosaurs in the movies. The primary productivity of an ecosystem is measured by how much solar energy and carbon dioxide is converted into usable organic material. Basically saying how much sunlight, water, and carbon dioxide is converted to food via the photosynthesis process, and that food is then used by the plants to make more leaves, fruits, seeds, etc. Then those are eaten by animals, and that energy then transfers through the ecosystem. With our modern day ecosystems facing habitat fragmentation and destruction as a major issue, I truly believe they wouldn't be able to sustain large populations of these large herbivores. If we look at large herbivores of today, many eat anywhere from 40 to 60 pounds per ton of body weight. A single 6-ton African elephant can eat around 340 pounds of vegetation a day. So, a single 26-ton apatosaur would need roughly around 880 pounds of plant matter in a single day. Now add a herd of 7-ton triceratops, 3-ton stegosaurs, 28-ton brachiosaurs, and all the other large herbivorous species that were featured, it really starts to add up. So it's easy to see that these species would not be able to become invasive just based on resource availability alone. They would hit their carrying capacity rather quickly. Plus, if we look at characteristics of modern-day animal invasive species, most have smaller body plans. Take zebra and quagga mussels or European house sparrows, for example. With smaller body plans, normally comes a fast growth rate and earlier sexual maturity and high reproductive potential. These large herbivores definitely don't show these characteristics, even though they might be able to outcompete our modern-day herbivores. They just won't make it. So the large herbivores would not become invasive and most likely would go extinct once again. And without the large herbivores, as a rule, the large carnivores would disappear too. Like the 5 to 8 ton Tyrannosaurus rex. Even though humans are an abundant food source. I mean, it would be a pretty terrifying life if T-Rexes were roaming around. That kind of brings up another point. In the history of humans, we really haven't gotten along with any of the megafauna species we've come in contact with. With large predators like Allosaurus, Carnotaurus, and Giganotosaurus attacking livestock, pets, and even people, I would bet my next paycheck on the fact that we would take out the large, dangerous ones out rather quickly. Not to mention poaching.
Dinosaur bone powder goes for what? 3,000 an ounce? Makes this animal here worth about, $500,000?
Wildlife black markets, the pet trade, and other ways we would exploit these species. Just like we do with our modern day species. I think it's safe to say that the large carnivores aren't going to become invasive. Alright, so we know the large herbivores and the large carnivores aren't going to become invasive. But what about those mid-sized species? I mean, in today's world, the hippopotamus in Colombia are the largest invasive species in the world, and they can weigh up to 2 tons. Whoa, 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 beep, 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 back the truck up here. There are invasive hippos in South America? Actually, yes. In the late 1970s, drug lord Pablo Escobar had a love for exotic animals and kept 4 hippos at his private residence. After his death, they were deemed too hard to handle and just left alone. Today, the estimated population is around 120. These large herbivores feed heavily on vegetation, thus having a negative impact on the ecosystem. Some similar sized species that were shown in the movie were the baryonyx, which was a small carnivorous species from the early Cretaceous period weighing about 2 tons, which is about the size of a hippo or large modern-day saltwater crocodile. Then there were the Altrosiraptors, chasing Chris Pratt and Bryce Dallas Howard in the streets of Malta, the Dilophosaurus, which in real life was a lot larger than the movies portray. This dinosaur was around 600 pounds and around 6 meters long. But let's take the genetically altered version from the movie, the little guy. These species would be almost the equivalent of a modern-day large predator ranging from a coyote to a lion or a bear becoming invasive. Again, highly unlikely, but not impossible. Even mid-sized predators and herbivores need a lot of energy and nutrients to sustain themselves. If we look at large invasive predators in our modern day, the Burmese python, the largest being around 220 pounds and 17 feet long, these reptiles have devastated southern Florida's ecosystem. In the 90s, Hurricane Andrew destroyed a couple of breeding facilities, dumping thousands of individuals into the ecosystem all at once.
Well, it has been 30 years since Hurricane Andrew slammed South Florida. This devastating storm is still on record as one of the fiercest hurricane landfalls in the country.
That gave the population a boost from the start, made it easier for them to find mates and to reproduce. Made it a lot easier than if 1 or 2 were to be released. And in the movie, it just didn't seem that many of these dinosaurs were dumped all at once into the same locations. So, if they did have high reproductive rates, it would take several years for them to become invasive. Plus, the python is an ectothermic organism, meaning they get their body heat from their environment. Or in plain terms, they're cold-blooded. Dinosaurs were endothermic. A crocodile or snake, or any other cold-blooded animal, can eat a single large meal and go days, weeks, even months without eating again, due to its slower metabolism. Warm-blooded animals like us, birds, and other mammals need to replenish our energy that's spent and lost on keeping our high internal body temperatures. So these predators, and herbivores at that matter, no matter the size, would need to eat a lot to maintain their homeostatic states. That's a lot of prey. So our modern day ecosystems would not be able to sustain large invasive populations of the large and most mid-sized dinosaurs. But what about those smaller guys? Like the Compsognathus, or Compies as they're referred to in the movies. Or even the Lystrosaurus and Microceratus. Now we start to see some invasive characteristics. Small body size, potentially high reproductive rates given the right conditions, and large numbers of these species probably would outcompete some of our modern day species. The Lystrosaurus, which isn't a dinosaur, but I'll still include it, is actually a mammal-like reptile about the size of a dog or small pig. And we all know about feral hogs.
A video on the porch of Glenn Gardner's Sienna home captures the midnight dinner party happening on his front lawn.
Not only that, the Lystrosaurus means shovel lizard, presumably because it burrowed with its powerful limbs. Sounds familiar again. It's really hard to tell how reproductive extinct species were, and even if our environment would have the right conditions, like temperature, humidity, etc. But again, this is for fun, and they were genetically modified, so we'll say that their reproduction is similar to that of hogs. Now, take into consideration that Lystrosaurus survived the Permian-Triassic extinction, which is one of the worst extinction events on the planet. This extinction ended the Paleozoic era, wiping out nearly 95% of all species. That just says that these guys are tough and adaptable. A very good candidate for invasive characteristics. Their populations boomed after the extinction event. So let's mark that one as potentially invasive. Now, what about those compies? Those terrifying yet adorable little basilisk-looking dinosaurs. These I can actually see becoming a problem, due to the fact that they have the same characteristics as the Lystrosaurus had: small-bodied, high reproductive potential, and very adaptable. These small dinosaurs would most likely fall prey to some of today's predators, like large birds of prey, big cats, coyotes, and quite a few others, including some of the other dinosaurs that are lurking around because, well, why not? Looking back on the fossil records, the compy's diet most likely consisted of invertebrates and small vertebrates. In fact, a fossil was found with a Bavarisaurus in the stomach. With all of that information, we can confidently say that our ecosystem can sustain a small omnivore like this. I say omnivore because, in the book, they used compies to reduce the amount of large herbivore waste on the island.
That is one big pile of shit.
Just a fun tidbit there for you if you haven't read the books. So there would be plenty of resources for these guys. From small rodents, birds, reptiles, and insects, to large amounts of waste from large herbivores, and the occasional kid, or tough guy in cargo pants. Plus, not to mention, these smaller dinosaurs would probably be labeled as cute, therefore be spread all around the world through the pet trade, like they were in the movie, and like many invasives are transported today for pets and then end up finding their way into our ecosystems. So of all of the 30 species of dinosaurs on Jurassic World Dominion, only about 2 or 3 have the capability of actually becoming invasive. Maybe a few more. Only about 10% of the original introduced species. But what about the most famous of all the dinosaurs in that franchise? The Velociraptor. In this case, Blue. Blue was shown to have reproduced, even though she was the last of her kind. This actually happens more than you think in nature. Usually in invertebrates, but some fishes, amphibians, birds, and reptiles are capable of this as well. This way of reproducing is known today as parthenogenesis. This is a natural form of asexual reproduction in which the mother pretty much clones herself. We only see Blue with one baby, Beta. But in Jurassic Park 3, we see that one Velociraptor nest contained many eggs. Now, maybe it's because Blue is more genetically altered than those ones from that movie, or because it's her first time reproducing, so fewer were born than she's capable of producing, or maybe wolves picked off the others. Who knows? Just for fun, let's throw in another biological phenomenon for Blue: temperature-dependent sex determination. In nature, many fish, crocodilians, many turtles, and lizards, Their sex is determined by the temperature during incubation. In some species, low temperatures will yield all females, and higher will yield males. And in others, it's vice versa. Blue is shown with a baby in the winter, and it's female. So, let's say it was incubated in lower temperatures. Now, what if both go through parthenogenesis during some warmer months and produce males? You see where I'm going with this. Now, if there were more than just one velociraptor introduced instead of just blue, then they could probably become invasive. A very competitive, aggressive predator? For sure. But since it's only blue, and now beta, them becoming an invasive species is highly unlikely. I mean, half of the population was rounded up in one day by poachers. The movie did cover one great example of an invasive species, though. That locust swarm that was devastating the ecology and the agriculture industry. This is a prime example of an invasive species. A new genetically modified species introduced into an ecosystem with very few natural predators to control its exploding population. It was said that its genes were from the Cretaceous, so that gives us a clue as to why it was so large. Larger than any other insect today. The oxygen level from the Cretaceous was about 30%, and again, today it's about 20.95%. So insects then would be able to sustain larger exoskeletons than the insects of today. That's why we don't see locusts that size today, and as the movie suggests, that's probably a good thing. But again, these are genetically modified and are able to live in our atmosphere. But Henry Wu saved the day by introducing a pathogen that altered their DNA. Modern techniques for controlling invasives are similar, like introducing triploid American bullfrogs into the population to breed with diploid wild frogs to not produce the next generation. So even if my childhood dream of dinosaurs being introduced into our modern world came true, they wouldn't take over as the movie kind of implies. And as for invasive ecology, I think our ecosystems are pretty well safe. From dinosaurs, that is. We have enough invasive species to worry about anyway. I really hope you enjoyed this video as much as I did making it and researching something that I've been kind of dreaming about since I was a little kid. If you did, if you learned something, and if you enjoyed it, please leave a like and a subscribe. I would really appreciate it, especially if you're new to the concept of invasive species. Until next time, drink local and plant native.
Yeah, but your scientists were so preoccupied with whether or not they could that they didn't stop to think if they should.